Hello, and welcome to the season finale of section 2.5. So this season on linear algebra, we learned, this section, we learned about LU factorization. Remember video 1, we learned how we can use it to solve matrix equations. Video 2, we learned how to actually calculate an LU factorization. And so as promised, here we're going to bring those two things together to solve the following problem. So just a quick note again, this problem is given to you in the week 3 worksheet as video 3, this exact problem. I highly recommend trying this out on your own. So if you haven't yet, pause the video here, work through this problem. All right, welcome back. So we're just going to find the LU factorization for A. So A is the matrix 4, 3, negative 5, negative 4, negative 5, 7, 8, 6, negative 8. And B is the vector 2, negative 4, 6. All right, so first step in finding an LU factorization, we want to row reduce A. And so then remember, at the same time that we are row reducing A, we will be reducing the identity matrix in the opposite way. And so remember here, for each row reduction step we do to A, we're going to do the opposite row reduction step to the identity matrix. Upon row reducing this, we'll be left with U, and we'll be left with L from this process. So first things first, let's do R1 plus R2. And so this one is going to have, or this problem actually, I'm very glad that I didn't actually initially realize this was going to be the case when I picked it. But I'm very glad this problem is going to have the quirk that it's going to have, just so we can sort of verify that this actually is the case. And so since I did R1 plus R2 here, I'm going to do negative R1 plus R2 here. Again, because I want the row reduction step that would go back this way. And so I guess in particular, notice, remember, I'm performing the row reduction step I'm performing down here is the row reduction step I'd perform to go this direction in my row reduction of A. All right, so this should be, so that's good. All right, so now I want to do negative 2, row 1 plus row 3. And so row 1 is going to stay the same. Row 2 will stay the same. The negative 4 or negative 8 and 8 cancel. Here, 3 times negative 2 plus 6 is 0. 10 minus 8 is 2. All right. And so again, the row operation that will get me back from this matrix to this matrix is 2R1 plus R3. And so that's exactly what I'm going to do to my identity matrix here. Or my, I guess now not an identity matrix anymore. So 1, 0, 0, negative 1, 1, 0, 2R1 plus R3, I get 2, 0, 1. And so notice this is a reduced echelon form matrix. And so I'm actually done. I've found both L and U. And so this matrix here is going to be my U, and this matrix here is going to be my L. And so the thing I want to point out, which I think can sometimes be a little confusing, notice there's still a 0 in this entry, but that's okay. The only thing we need to check to verify that L is in fact a lower triangular matrix is that I get the triangle of zeros above the diagonal there. I can have any entries I want down here. And so it's okay that I have a 0 here. So U is a echelon form of A. L is a lower triangular matrix. And so we have A equals L U. So what I'm going to do is I'm going to rewrite L and U down here so that I have this space to work. So we'll say U is equal to, I'll copy U and then I can erase it. -5, 0, -2, 2, 0, 0, 2. All right, and now L is equal to 1, 0, 0. Make that one a little clearer. -1, 1, 0, and 2, 0, 1. Just like that. And so we've got our LU factorization. Now we want to use it to solve the matrix equation AX equals B. So remember, for this, we do this sort of in 2 steps. So we actually don't want to solve AX equals B, right? So remember, we want to instead work with LU times X equals B. And so because of this, remember, step 1 to solving this is to solve first the matrix equation Ly equals B. Well, so I've got L, I've got my vector B, and so here to solve Ly equals B, I can just set up the augmented matrix. And so what's fun about math is that, you know, I whenever I do this, I always learn new things. And so I actually didn't notice this fact until I was row reducing this matrix. But take special note of the row operations we do to solve this matrix equation, because they might look somewhat familiar. So to solve this, I want to just put it in reduced row echelon form. So first I'm going to do row 1 plus row 2. And then lastly, I'm going to do -2, row 1 plus row 3. And so why these should look familiar, and you know, I think what's interesting about it is we're just using the same sequence of row reduction steps we used to transform A into U, because ultimately what we're doing to solve this equation is we're transforming L into the identity matrix and then sort of looking at what happens to this vector B as we perform those same row steps. And so another reason, sort of, you know, if you're wanting to solve multiple equations, that an LU factorization could be very useful, is that this first step, you're always going to use the exact same sequence of row steps every time, just with a new vector B. So you could see how it would speed things up, because you might be able to sort of shorten the process because you're just going to use the same sequence of row steps over and over and over. So anyways, so the solution to this equation is the vector y, which is 2, -2, 2. All right, so step 1 towards solving this using LU factorization is done. Again, I'll keep this, I'll keep the vector y, but I'm going to erase the row reduction steps just so we can have room to do our next row reduction. So here we got that y was equal to 2, -2, 2. And so our last step here in solving the matrix equation now is to solve the matrix equation ux equals y. And so we're going to solve this the same way. Granted, it'll take a few more row reduction steps this time around. 4, 3, negative 5, 0, negative 2, 2, 0, 0, 2, and then I'll augment this matrix by y. All right, so first things first, I'm going to divide both rows 2 and 3. So I'll divide row 2 by negative 1/2 and row 3 by positive 1/2, just to get ones where I want them. All right, now I'm going to use this one here to clear out the column above. So this will be row 3 plus row 2, and 5 row 3 plus row 1. And because I cannot be trusted with arithmetic, I did this arithmetic earlier and checked to make sure it was correct. I get that. All right, so we're almost there. Now we want to use row 2 to clear out this 3 here, so we'll do negative 3 row 2 plus row 1. And so that gets me 4, 0, 0, 1, 0, 1, 0, 2, 0, 0, 0, nope, don't want a 0 there, 1, 1. And last but not least, we'll do 1/4 row 1 to get 1, 0, 0, 1/4, 0, 1, 0, 2, 0, 0, 1, 1. All right, and so that actually gets me a solution to the original matrix equation. So this gives me the solution x equals 1/4 to 1, which again is a actual solution to the problem. And so again, this vector x here would be a solution to the original matrix equation ax equals b, where this is a and this is b. And so that's sort of the entire process of how we use LU factorization. And so that actually, I think, wraps up chapter 2. So this, following the schedule, will be the Thursday video for week 3. So tomorrow we'll move into chapter 3.